For question 1 Roman, try to sketch by your own and then expand your original graph from -3 until 3. So this is the answer for the question 1 Roman. In the dotted line here is the original graph from -1 until 1. On the left hand side and the right hand side here, this is the graph that we expand from -3 until 3. For the question 2 Roman, from 1, determine whether it is an odd, even or neither function. So from the graph that you have sketched here, you have to determine your types of the graph. From the original graph here, you have one graph at the bottom side and one graph at the upper side. So this one is not an odd function. Why this one is not an odd function? Because the range here is 2 and the range at the upper side is 1. Okay, so that's why this one is not symmetric at origin, because the range here is not the same thing. So this graph is neither function. So give reason for your answer if the question asks. So the reason is not symmetric at origin and not symmetric at y-axis. So now let us proceed for the question 3 Roman. Find its Fourier series expansion. So in order to find the Fourier series expansion, we have to find all the value for the Fourier series coefficient, whereby you have to calculate the value for a0, an, and bn. So since our graph is a neither function, so we will use this formula in order to calculate a0, an, and bn. So we copy down first all of this formula. So before we want to substitute into this formula, we have to determine the value of L. So from where you have to determine the value of L, refer back to your question. Okay, so this is our function. In order to determine the value of L, you can refer to the highest limit here. So our L is equal to 1. Or you can refer to the periodic function here, fx plus 2, whereby 2L is equal to 2. So therefore L is equal to 1. So either one will be accepted. So therefore our L is equal to 1. So first we calculate for a0. a0 is equal to 1 over L, integrate from -L until L, fx dx. So we have determined our L is equal to 1. So we will substitute L equal to 1. Substitute L equal to 1 and fx into the formula. So we get the value of L from the question, and this fx we also will obtain from the question here. So therefore 1 over L will become 1. 1 over 1, integrate -1, 1, fx dx. So we want to integrate from -1 until 1. But in this function, we have from -1 until 0 and then 0 until 1. So means that we have to separate the limit according to the question. So therefore this one will become 1 over 1. We can directly ignore because 1 over 1 will become 1. So we want to separate the limit -1 until 1 according to the question. So according to the question, we have -1 until 0. -1 until 0. fx, our fx is equal to -2. -2 dx plus from 0 until 1. 0 until 1. Our fx is equal to 1. 1 dx. So this is what we mean by you have to separate your fx according to the limit. So the first limit from negative 1 until 0 for the function negative 2. For the second limit from 0 until 1, 0 until 1, whereby your fx is equal to 1. The smallest value is always at the bottom side, the largest value at the upper side. So now we have to integrate negative 2 and integrate 1. Integrate negative 2 will become negative 2x. So we don't have plus c here. Why we don't have plus c? Because we have the limit. So we have to substitute the limit to the position of x. Negative 1 until 0 plus integrate 1 will become x. The limit from 0 until 1. So now substitute the limit. So we will substitute the highest value minus the smallest value. Negative 2 multiply 0 minus negative 2 multiply negative 1. So this one is for the limit negative 1 until 0. Plus, substitute for the second one. 1 substitute to the x will become 1 minus 0 to the x will become 0. Simplify. Negative 2 multiply 0 minus negative 2 multiply negative 1. Negative 2 multiply 0 will become 0. Negative 2 multiply negative 1 will become 2. 0 minus with 2 will become negative 2. Plus 1 minus 0 will become 1. So therefore negative 2 plus with 1 will become negative 1. So this is the answer for the A naught. So now let us continue for the second Fourier series coefficient, whereby you have to calculate the AN. So copy down the formula. So now we will substitute the value of L. Our L is equal to 1. 1 over 1 negative 1 1 fx cos and pi x over L will become 1. So we want to integrate from negative 1 to 1, the same concept. The question here, you have negative 1 until 0 and then 0 until 1. So means that we have to separate according to the given limit, which is from negative 1 until 0 plus 0 until 1. So 1 over 1 can be simplified. We just write as 1. Negative 1 until 0. Our fx is equal to negative 2. Negative 2 cos n pi x over 1. So n pi x divide with 1 will become n pi x. Dx plus the second limit 0 until 1. Our fx is equal to 1. Cos n pi x dx. So now we want to integrate. Before this, we only integrate a constant 2 and 1. But now we have constant multiply with a trigonometric function. Now we want to integrate negative 2 multiply with the cos. First, we bring the constant to the front. Negative 2 integrate negative 1 0 cos n pi x dx plus, so this one 1, so there is nothing that you have to bring to the front because it's only the value of 1. So 0 1 cos n pi x dx. So now we want to integrate cos. So from here, from integrate, our answer will become for this part. So integrate cos means that integrate cos will become sine. Negative 2 is a constant at the front. Integrate cos will become sine n pi x. Divide with, differentiate the argument, you have to write at the bottom side. So if we have cos 2x, when we integrate cos 2x, this one will become sine 2x divided with 2. So why we have 2 at the bottom side here? Because we differentiate 2x and then we write at the bottom side. Differentiate 2x will become 2. So the same concept here, we will differentiate n pi x. So differentiate n pi x will become n pi. So we write n pi at the bottom side. The limit is from negative 1 until 0. Integrate for the second one, integrate cos n pi x plus the same thing, this one will become sine n pi x divided with n pi, 0 until 1. So you have to write both because the limit is not the same value. So now substitute the limit. Substitute the limit of 0 minus limit of negative 1. So substitute 0 into x. Negative 2 sine n pi multiply with the 0, and pi multiply 0 will become 0. So this one will become sine 0 divided with n pi minus sine, substitute negative 1 to the position of x, and pi multiply negative 1 will become negative n pi. So this one will become sine negative n pi divided with n pi. Plus, substitute the second limit, sine n pi x, x will become 1. N pi multiply 1 will become n pi. So this one will become sine n pi. Sine n pi divided with n pi minus 0, substitute to the position of x, n pi multiply 0 will become 0. So this one sine of 0 divided with n pi. So now we will apply sine negative n pi and sine n pi from the table that I have mentioned before this. Sine n pi is equal to 0. Sine negative n pi is also equal to 0. So therefore, sine negative n pi, this one will become 0. Sine n pi also will become 0. For the sine 0, you can use the calculator. The answer is also 0. So 2 multiply with anything that contain the value of 0. So this one, the whole thing will become 0. So the same thing for the bottom side here. This one will become 0. So 0 plus with 0 will become 0. So therefore, the Fourier coefficient for the an is equal to 0. So for the next Fourier series coefficient, Bn is equal to 1 over L integrate from negative L to L, fx multiply with the sine. So copy down the formula. So the same step, we have to substitute the value of L become 1. 1 over 1, negative 1, 1, fx sine and pi x over 1 dx. So the limit here from negative 1 until 1, whereby to separate according to the given limit. So therefore, 1 from 1 here, you don't have to write. Integrate from negative 1 until 0. Our fx is equal to negative 2 sine n pi x over 1 will become n pi x. plus the limit from 0 until 1 sine n pi x dx. So now we want to integrate -2 multiply with the sign. So if you have any constant, it depends whether you want to bring to the outside or not. So I will bring the constant to the outside. -2 if we integrate negative sign, the answer will become positive cos. But now we want to integrate positive sign. So means that we have to move this negative to the other side, whereby the answer here will become negative cos. -2 negative cos n pi x. The same thing, we have to differentiate the argument n pi x and then write at the bottom side n pi. Substitute the limit from -1 until 0 plus integrate sine n pi x. So integrate positive sign will become negative cos. So now substitute the limit 0 to the position of x. So this one will become -2 negative cos n pi x. Substitute 0 and pi multiply 0 will become 0. So this one will become cos of 0 divided with n pi minus. So make it in bracket because we have minus cos. N pi x, x become -1. And pi multiply -1 will become negative n pi. So therefore this one negative n pi divide with n pi. So close the bracket plus. So now substitute the second limit 1 to the position of x. And pi multiply 1 will become n pi. So therefore this one will become negative cos of n pi divided with n pi minus in the bracket negative cos 0 to the position of x and pi multiply 0 will become 0. So cos of 0 divided with n pi. So now you have to simplify. Cos of 0 by using the calculator will become 1. So cos of 0 is 1. Cos negative n pi and cos n pi, you have to refer to the table before this. Cos n pi is equal to -1 the power of n. Cos negative n pi will become -1 the power of n. So therefore this one will become -1 the power of n. This one is also -1 the power of 1. So simplify more. So therefore -2 in this big bracket, -1 over n pi. -1 over n pi minus will become plus. -1 the power of n divide with n pi. -1 in the bracket power of n divide with n pi. So close the bracket plus with answer in this bracket. -1 the power of n divide with n pi. So make it in bracket -1 the power of n divide with n pi. Negative will become plus 1 over n pi. So if we have a constant at the outside here, we have to multiply inside. So -2 multiply -1 will become 2 over n pi. -2 multiply -1 the power of n. -2 -1 the power of n divide with n pi. Plus minus will become minus -1 the power of n divide with n pi. Plus will become plus 1 over n pi. So now simplify 2 over n pi plus with 1 over n pi. 2 plus with the 1 will become 3 over n pi. Negative 2, negative 1 the power of n divided with n pi, minus negative 1 the power of n divided with n pi. So we have negative 2, negative 1 will become negative 3. Negative 3, negative 1 the power of n divided with n pi. So from here, if we can see both of the terms here, you have n over pi and 3 at the upper side. So we can factorize the same term. So the same term that we have is 3 over n pi and 3 over n pi. So we factorize 3 over n pi. 3 over n pi at the outside. So in this big bracket, will become 3 over n pi multiply with what? So that it will become 3 over n pi. So this one will be multiplied with 1. 3 over n pi multiply with what? So that it will become negative 3 multiply with the negative 1 the power of n divided with n pi. So this one minus negative 1 n. So this is the answer for our Bn. For this example, our Bn is equal to 3 over n pi multiply the whole thing with 1 minus negative 1 the power of n. So if we have 1 minus negative 1 the power of n, we can simplify more. So how to simplify more? So we have 1 minus negative 1 the power of n. So this one is equal to 1 plus negative 1 the power of 1, negative 1 the power of n. So negative 1 the power of 1 here is the same thing as negative sign here, because negative 1 the power of 1 is equal to negative. So therefore, if we have negative 1 the power of 1 multiply with the negative 1 the power of n, so we will plus the power here. So therefore, this one will become 1 plus negative 1 n plus 1. So that is what I mean by if we have 1 minus negative 1 the power of n, we can simplify more, whereby it will become 1 plus negative 1 the power of n plus 1. But if we have 1 plus negative 1 the power of n here, then there is no need to simplify more, because this is the answer that we have to proceed. But if you have 1 minus negative 1 the power of n, so you can simplify more your answer to make it become 1 plus negative 1 the power of n plus 1. So this one is not compulsory for you to simplify. It depends on your question. If the question asks you to show that your answer is in terms of the power of n plus 1, then you have to simplify. If the question is not mention anything, then you can just proceed your final answer with the 1 minus negative 1 the power of n. Okay, now we will continue to write the Fourier series expansion. So you have to copy down the formula for the Fourier series expansion, whereby you have fx is equal to a naught over 2 plus summation n equal to 1 until infinity. In this big bracket, you have to write an multiply with the cos plus bn multiply with the sine. So we have to substitute all the value that we have find before this, a naught, an and bn, into this formula. So since we have simplified the value for the bn, we have first option and second option in order to write your final answer. So for the first option, this one is the answer whereby we are not simplify the 1 minus negative 1 the power of n. For the second option, this one I have simplified the 1 minus negative 1 the power of n, whereby this one is become 1 plus negative 1 the power of n plus 1. So therefore, the Fourier series expansion for the first option, this one will become a naught over 2. So a naught will become negative 1. So therefore negative 1 over 2 plus summation n equal to 1 until infinity in this big bracket. So an, we will substitute an equal to 0. 0 multiply with the cos n pi x over 1, whereby our L is equal to 1, plus bn. So for the first option, our bn is equal to 3 over n pi 1 minus negative 1 the power of n. 3 over n pi 1 minus negative 1 the power of n multiply with the sin n pi x over L. Sin n pi x over 1. So close the big bracket. So now you have to simplify negative 1 over 2 plus summation n equal to 1 until infinity. 0 multiply with anything will become 0. So therefore we only have to write 3 over n pi. 3 over n pi 1 minus negative 1 the power of n sin n pi x. Okay, so make it in big bracket. So this is the final answer for the Fourier series expansion, whereby we use the answer for the first option. So if we want to use the answer for the second option, whereby our bn is equal to 1 plus negative 1 the power of n plus 1. So therefore our final answer will become fx is equal to negative 1 over 2 plus summation n equal to 1 until infinity. So since our a naught is equal to 0, so this one will become 0. So we only proceed for the bn here. 3 over n pi 1 plus negative 1 the power of n plus 1 sin n pi x. So this is the final answer for the Fourier series expansion, whereby we use the second option for the answer of bn. So if you compare the answer here, so I give two options, whereby this one in terms of n plus 1, this one in terms of negative 1 the power of n. So both of these answer will be accepted. There is no problem either you want to use n plus 1 or the power of n.